Hey guys, so today you and I are going to talk about corporate developers and cross observations. So let's get into it. So the question in question was, Frederick, do you ever leverage as a corporate developer? Do you ever leverage? It's funny that have you been checking on my CV? Do you ever leverage observation of the implementation in, say, video games that you play to find unique ways to cross-apply the ideas to the code that you are developing? Uh, so what you're saying is that have I made observations of things in video games that I find useful in my own work? Well, uh, I it's difficult for me to say that I can think of a video game where I've done this. I do play video games. I like that's one of my ways of really relaxing for sure. It's been a hobby since I was like 6 years old. So as I like to say to people who think this or that about it, I kind of go, "That's my football. Your dad and your whoever who's doing whatever, like they grew up with football, I grew up with video games, and I can often find myself appreciating video games and people who make video games and clever or things that I think are very clever in the game in a different way than when I wasn't a programmer. One of my favorite ones is when I see a series such as, say, the Assassin's Creed games, to see sort of how they evolve the mechanics from the previous game, and it's almost the sensation where they sort of, I'm not going to say too much because I've never really looked into it, but I get the sensation that they have sort of achieved the thing that a lot of software companies want, where they create a framework for work. They've created a very nice framework of work where they can build new games without having to start over from scratch every time. So there's always a red thread in the development. It's almost like they have a game platform that they have like the base components and base mechanics and physics and so forth that they can add on top of as a base layer, and then on top add the next set of functionality. I mean, sooner or later, Assassin's Creed is probably going to be the next Sims at some point where you're just going to be able to live in that world. I hope so. At the very least, that would be a very awesome game. But for me, usually the things that I see that like cross usages of, it's not so much video games because apart from the video games that I've made myself, what is it, the ECS patterns and so forth, like these different game style ways of working. It's very rare. I can't really recall a time when that made sense for me in a corporate environment. The thing that has made a lot of sense to me though is the diverse. I have a broad interest in IT, and I am always surprised at how certain observations that I make in other areas starts making sense in the work that I do as a software developer. Now, this is one of those situations where I can give you probably fairly concrete examples of situations where I've found where my way of thinking has been influenced by something that I have seen somewhere else, right? So, as an example, I had took a course in graph theory, basically, where the issue that I had, or rather, it was a course in graph theory, and I have never really learned graph theory before I became a software developer. But when I was looking at it, and we were learning about Dijkstra's algorithm, etc., etc., like there are many different graphs and topological sorting and so forth. The concepts that I was learning and the sort of the way of thinking of solving problems made it actually very possible for me in my work to start figuring out how to solve most of the dependency problems that I had within the company. So basically, what just the understanding of how graph theory actually works, and the sort of problems that it is attempting to solve, and the methodologies that we have, like the sort of standard ways of solving certain problems that we have. By going through those exercises, I started understanding the like how to structure code solutions, or rather I had a solution that I realized now that the reason why this is working is actually a graph problem. An example, a concrete example would be refactors. So if when you're going to do a migration, like in as I'm doing right now with a code base that we're migrating from old code to new code, or as we call it, the golden path technologies that we're going to follow in the company. So the question always becomes, okay, so how do you facilitate that migration? Because you're basically moving all the business logic from one place to another. And as I was saying, because I have had some basic training in graph theory, I start to think, my mind immediately goes to, well, probably the best way to approach this problem is to find a leaf node somewhere, because it's going to be a tree. Like all the logic is going to end up being a tree in some fashion, where the entry point into the tree is the end point, and the last node in the tree is going to be a set of nodes, or like the bottom layer of the tree, the bottom level is going to be access to databases, so external networks or something like that. So since those are probably the only pieces of code that I could move that do not have a dependency, let's start there, because that's going to be the lowest impact that I can have. It's the least risky thing that I can move without breaking a lot of other stuff. And so I lovingly call this picking leaves from the dependency graph. And the way that it's done is actually very simple. You go and pick the thing that it has the least amount of dependencies, and you move that into the new structure. You refactor that piece and then make it backwards compatible with the old stuff for a little while. Sometimes I have to put like an adapter in between, because in some cases you're migrating from like a very, let's just say, like in this scenario it was a Nest.js application to a Next application, and Nest uses a lot of annotations and custom syntactic sugar for the framework, which we don't want in the new stack. We want that to just be ES6 in this scenario. So in order to make that happen, you have to figure out, okay, how can you decouple this code from the way that Nest does it? And this is exactly how we did that, by just using the basic principles of graph theory to basically create a sort order, or like a topological sort, where you know that here's a graph of nodes that are all connected. They're all dependencies, just as objects are in object-oriented programming, and you order them in the way where you can pick the thing that has no downstream connections. And then you keep on picking until you make it all the way up to the endpoint, and then you are left with just the URL, like the network interface that you need in order to hit the service layer, like all the logic that you might have within that endpoint. And when you're in that state, then it's actually very easy. Just move the service, instantiate it in the new server, and you've migrated your endpoint, right? And I find over and over that these sorts of observation. This is the reason why I tell people that I know that it's scary with algorithms, guys. I know it's sometimes scary with computer science and stuff like that. But a lot of these concepts, it's the same thing with mathematics. The thing is, when you understand it and you sort of understand this very high level, because it is very generic. Graph theory is a very generic topic. But when you truly understand the lessons that these areas have to teach you, you start to see the patterns in your everyday life. It really does take some effort to get there, but I continuously see the same thing over and over. An example is right now, where I've realized that my understanding of security work and how man-in-the-middle attacks and like all different types of man-in-the-middle attacks work, it's actually something that I just the other day had this realization that one of my coworkers came to me and he said, "Frederick, how can we fix this problem?" And I go, "What problem?" "Well, we have all of these systems that all connect to each other, and we want to apply the DORA metrics to the work process of all the teams. But we're struggling a bit with figuring out how we can measure connectivity between systems and network latencies and things like that." And I go, "Are we using SDSO or like a service mesh or something?" "Nope." "Do we have, like, we could do a lazy thing and just look at the logs or something, but maybe we can do the thing that I'm working on." And he goes, "Well, What are you working on? Well, I'm working on creating clients that connect to each of these services, and because what I'm trying to achieve is that if all the systems are produces network clients or REST clients that can be consumed by the other systems, then what happens is that we get a point where we, as the maintainers of the clients, can inject code and metrics and observe and analyze the connections between the different systems. Now, if you use STSO or like a service mesh, you can get that sort of thing for free. For us, it's not been very easy to get that to happen, but this is something very sustainable. And what's awesome about that is that that means that we have our code sitting between the client system and, well, the end system, and that is in effect a it's not a man-in-the-middle attack, but you can listen in, or you can create a situation where you can control the communication between two systems at the code level. So these are, like, I know this sounds very fluffy, guys, but this is the sort of stuff that I find over and over, that the more stuff I learn, the more things I can sort of see are relevant from one area over to another. So what I want you to take away from this is that, yes, I can definitely testify to that, well, not specifically video games, but learning a lot of different stuff and being inspired by different stuff. Incidentally, guys, if you didn't think about that, machine learning and like modern day AI is the same sort of thing. These mathematical models that we're using, these are inspired by how the human brain works and neurons and so forth. Like we're trying to, like genetic algorithms, all of this good stuff. It's based on mimicking something that is happening in nature and applying it in computer science. And that's something I like to remind people about when we talk about software development, guys. Almost everything you do as a software developer is to digitalize a physical process or entity or something like that. That's what, in place, if you didn't think about that, Amazon and like cloud hosting, a lot of the stuff that you have in, like, you used to have like physical routers, physical servers, and so forth, and firewalls, like physical firewalls, like actual devices, and you still do, but a lot of that stuff has been moved to the cloud. But the concept, like the thing that still exists, it's just that it's virtual now. It's something that I always find interesting to remind myself about. And so I definitely encourage anybody to who wants to have a sort of a very good sixth sense of good solutions to different problems that you find as you work as a software developer, to try to explore a little bit. Look at, maybe now that you have a job, or if you've made it that far and so forth and you've been working for a while, take a course like I did in graph theory or something like that. Doesn't have to be the most serious thing in the world. Just take it and see if you get inspired in thinking in a different way. Or maybe take that course in functional programming, or learn a little bit about Haskell or something. You don't have to be die hard about it. Just be inspired by other things. Then I promise you, you're going to start to see some overlap in the work that you do. Have a great day.